We have an equation, and normally we want to kick this off with PEMDAS in reverse, but anytime, this one's a little bit different in that we have an x underneath the square root symbol and one that's not underneath the square root symbol. So when that happens, our first order of business is to get that radical by itself and then get rid of the radical. Now in this particular example, the radical is already by itself, but normally I'd be checking outside the radical to see is there anything to add or subtract on this side or multiply or divide on this side, and there is not. So I'm just going to get rid of this radical. The way to get rid of a radical is by using the corresponding opposite power. If there's no number listed here, we do assume it's a 2. So I'm going to square both sides. The square on this side will cancel out the radical, leaving just 9 plus x. And when we square this side, we end up getting x squared plus 14x plus 49. Whoa. That's too messy. X squared plus 14x plus 49 is going to equal 9 plus x. If you're not sure where this expression is coming from, it is taking that x plus 7, multiplying it by itself by FOILing everything out and combining like terms to get this expression over here. At this point, I do recognize that I have an x squared term and some x terms. That means this is quadratic. That means one side must equal 0 before I can go further. So it's always smart to keep the x squared term positive. So I'm going to subtract an x from both sides and line up like terms, subtract 9 from both sides, and end up with what I can hopefully write neatly, x squared. These combine to make positive 13x, and these combine to make positive 40 equal to 0. Now, this will likely be factorable. If it's not, we can use the quadratic formula, of course, but I'm going to see if I can't think of things that multiply to make x squared. That's x and x. For 40, I have choices like, well, 1 and 40, 2 and 20, 3 doesn't go in, 4 goes in 10 times, and 5 and 8. And that's all the choices I have. Because it's a positive 40, I know they'll have the same sign. So I'm trying to find which factor pair is going to combine to make that positive 13. So that would be this positive 5 and positive 8 equal to 0. Because this times this has to equal 0, either x plus 5 equals 0 or x plus 8 could equal 0. If x plus 5 equals 0, x equals subtracting 5 from both sides, negative 5, or subtracting 8, maybe negative 8. So these are my potential answers. I do want to take both of these numbers in the original problem, plug them in, and make sure that they actually work. If they don't work, I cross them off. If they both get crossed off, there's no solution. That could totally happen. So let's take the negative 5. If x equals negative 5 in the original problem, I get negative 5 plus 7, and I'm wondering, does that equal the square root of 9 plus negative 5? Well, these guys combine to make positive 2. 9 plus negative 5 is 4, so I get the square root of 4. The square root of 4 is 2, so I get the statement 2 equals 2. That's true. 2 equals 2. That's definitely an answer. That happened when x was negative 5, so that's an answer. Now, if x is negative 8, I'm going to go back to that original problem and do a very similar thing. Let me pause and erase. So if x equals negative 8, I get negative 8 plus 7 equals the square root of 9 plus a negative 8. These guys combine to make negative 1. 9 combined with negative 8 make positive 1. The square root of positive 1 is 1. I get the statement negative 1 equals 1. Negative 1 does not equal 1. That is not correct. So this answer that gave me this untrue thing is not an answer. The only answer is x equals negative 5. Good luck. Be patient, take your time, do one thing at a time, don't rush. Just be awesome at it.